Section 1. Steel, Fire, and the Clock. September 27, 1941. Richmond, California. The fog hangs low over the shipyard, heavy with the smell of salt water, oil, and hot steel. Floodlights burn through the gray dawn, illuminating a forest of cranes frozen mid-swing like metal giants holding their breath. Somewhere deep inside yard number 2, sparks explode in white flashes as welding torches bite into steel plate. Henry J. Kaiser stands on a raised platform, hands shoved deep into the pockets of his overcoat. He is not a naval officer, not an admiral, not even a trained shipbuilder in the traditional sense. He is a construction man, a builder of roads, dams, and bridges. And he is staring at the ocean as if it has personally insulted him. A foreman shouts over the noise, "Mr. Kaiser, plate section's ready to lift." Kaiser nods once. His eyes never leave the half-assembled hull below. Out in the Atlantic, German U-boats are already killing faster than Britain, or anyone else, can replace what's lost. Convoys burn at night. Survivors freeze in open water. Every week, the numbers grow worse. More ships sunk than built, more cargo lost than delivered. If America enters the war, when America enters the war, this imbalance will decide everything. Kaiser knows the math. He also knows the old way of building ships will never be fast enough. Below him, workers guide a massive prefabricated hull section into place. Instead of the staccato hammering of rivets, the sound that has defined shipyards for half a century, there is only the low hiss of gas and the violent crackle of electric arcs. Welders move in tight formations, sealing seams in long, continuous lines. No rivets, no overlapping plates, just steel fused directly to steel. A Navy observer nearby shifts uneasily. "Sir," he says, raising his voice, "the Bureau of Ships still has concerns about welded hull integrity, cracking, brittleness, especially in cold water." Kaiser finally turns. His expression is calm, almost bored. "Rivets fail too," he says. "They just fail slower." The observer opens his mouth, then closes it again. This ship, one of the first Liberty ships, is not elegant. It has blunt lines, slab sides, and no unnecessary curves. Its triple expansion steam engine is obsolete by naval standards. Its speed will barely exceed 11 knots. It is not designed to fight. It is designed to exist and to be built fast, very fast. Across the yard, a chalkboard hangs from a wooden post. Someone has written a number at the top, 240 days. That is how long it traditionally takes to build a cargo ship from keel to launch using riveted construction. Kaiser walks to the board, takes the chalk and draws a hard line through the number. Beneath it he writes, 60 days. Then, after a pause, he underlines it twice. For the men watching, it feels absurd, maybe even dangerous. Shipbuilding is supposed to be slow, methodical, conservative. The sea punishes mistakes mercilessly. But Kaiser is not thinking like a shipbuilder. He is thinking like a man racing a stopwatch and losing. The innovation itself is deceptively simple. Instead of assembling ships piece by piece in sequence, Kaiser's engineers break the hull into standardized modules: bow sections, stern blocks, midship compartments, deck houses. Each is built simultaneously in separate stations, welded together on land by semi-skilled laborers trained in weeks instead of years. When ready, cranes lift these massive sections and lower them into place like parts of a giant industrial puzzle. No waiting for rivet teams, no bottlenecks, no idle time. The Germans do not know it yet. But the rules of the naval war are already changing. On the East Coast, U-boat commanders log another successful night. Tankers explode, freighters vanish. The Kriegsmarine believes it has found the pressure point: strangle Britain, starve the Allies, and force a negotiated peace. What they cannot see is Richmond, or Portland, or Baltimore, or the dozens of shipyards rising seemingly overnight along America's coasts, staffed by men too old to be drafted. Women who have never held a torch before, and farmers who learned to weld last month. They work in shifts around the clock. When one crew leaves, another steps into the same footprint, torches still warm. Ships take shape in weeks, sometimes days. In Washington, skeptical Navy officials read production reports twice, assuming clerical errors. They are not errors. They are warnings. On the morning of December 7th, 1941, Kaiser will be in his office when the radio crackles with news from Hawaii. Pearl Harbor. Battleships burning. America at war. He will not panic. He will pick up the phone and say only this: "Then we need more ships, and we need them now." Out on the slipway, as another Liberty ship slides into the water under a spray of champagne and steam, no one cheers for long. The cranes are already swinging back into position. New sections are waiting. The ocean is hungry, and for the first time, America is preparing to feed it faster than it can bite. Section 2. Rivets, Warnings, and a Calculated Risk. January 14th, 1942. Washington, D.C. Snow dusts the steps of the Navy Department building as senior officers file into a windowless conference room deep inside the Bureau of Ships. The mood is tight. Ashtrays are already full. Coffee has gone cold. Pinned to the wall is a large chart of the Atlantic. Red grease pencil marks dot the shipping lanes like spreading infection. Each mark represents a ship sunk since Pearl Harbor. A rear admiral clears his throat. "Gentlemen, our losses now exceed 700,000 tons per month." No one speaks. Another officer, younger, more cautious, gestures toward a stack of reports. "We are building faster than before, but not fast enough." Then comes the uncomfortable part. A civilian engineer, one of Kaiser's men, stands and adjusts his tie. He does not wear a uniform, and that alone irritates several people in the room. "We believe the bottleneck is not steel," he says. "It's tradition." A murmur ripples across the table. He continues anyway. "Riveted construction requires skilled crews that take years to train. Welding allows us to train workers in weeks. Modular assembly allows us to build ships in parallel instead of sequence." An admiral leans forward. "And what happens when these welded ships crack in half in the North Atlantic?" The engineer nods. He has expected this. Some already have. That gets their attention. In cold conditions, poorly controlled welding can create brittle fracture points. We've seen failures. Hulls breaking catastrophically. A pause. "But we know why," he adds quickly. "Steel composition, welding procedures, stress concentration at square hatch corners. These are engineering problems, not reasons to abandon the method." The room is silent now. At the far end of the table, a man who has not spoken finally does. Admiral Emory S. Land, head of the U.S. Maritime Commission. "How long," Land asks, "to fix it?" The engineer answers honestly. "Weeks, maybe months." Land nods slowly. "And if we go back to rivets?" "Years," the engineer replies. That settles it. The decision is not unanimous. It is not comfortable. But it is final. America will weld its way to victory and accept the losses along the way. Back in the shipyards, the pressure intensifies immediately. Posters appear overnight. Ships are weapons. Build them fast. Welders are retrained. New steel alloys are specified with better low-temperature performance. Sharp internal corners are rounded. Reinforcement straps are added along stress-prone seams. Failures are not hidden. They are studied. When a Liberty ship splits in two off the coast of Alaska, photographs circulate through every yard within days. Engineers mark fracture lines in chalk, argue over grain boundaries, revise procedures. Then they build again, and faster. By mid-1942, something unprecedented begins to happen. Completion times fall below 50 days, then 40, then 30. At Richmond, Kaiser challenges his own managers to a stunt. Part publicity, part proof of concept. The ship is named SS Robert E. Peary, after the Arctic explorer. Everything about her construction is planned like a military operation. Components are pre-staged. Crews rehearse. Welders work in perfectly timed rotations. On November 8, 1942, a stopwatch starts. 4 days later, 4 days, 15 hours, and 29 minutes. The Peary slides into the water. Reporters stare in disbelief. Navy officers shake their heads. German intelligence officers dismiss it as propaganda, but it isn't, and it isn't a one-off. By early 1943, Liberty ships are launching faster than U-boats can sink them. The Atlantic balance begins to shift. Quietly at first. Convoys still lose ships, but the gaps close. Cargo arrives anyway. Fuel, ammunition, trucks, food. A German U-boat commander writes in his log, "Sinkings no longer reduce enemy traffic." It is an observation, not yet a realization. Meanwhile, the workforce itself has transformed. Women welders, Rosie the riveters, though many never touch a rivet, climb scaffolding with torches blazing. African-American workers, long excluded from skilled trades, become indispensable in yards that cannot afford discrimination. This is not just industrial output. It is industrial mobilization. Kaiser walks his yards constantly. He talks to foremen, welders, crane operators. He is not beloved, but he is respected, because he measures success in ships launched, not excuses made. When asked about the cracked hulls, he replies bluntly, "A cracked ship that delivers cargo once is better than a perfect ship that never gets built." By late 1943, the Germans finally understand what they are facing. BDU reports show sinkings rising, but Allied shipping rising faster. Escort carriers appear where none existed before. Radar-guided patrols tighten the noose. U-boats are no longer hunting freely. They are being hunted. And behind every convoy, behind every escort, behind every advancing army, there is steel welded at speed, built by shortcuts that weren't shortcuts at all, but a new way of thinking. The Atlantic has become an equation Germany cannot solve, because for every ship they sink, 2 more are already sliding down the ways. And somewhere in California, sparks continue to fly in the fog. Section 3. The Wolf's Realization. March 19, 1943. North Atlantic, west of Ireland. The sea is slate gray, rolling in heavy, uneven swells that slap against the pressure hull of U-384, a Type 7 German submarine running at periscope depth. Inside, the air smells of diesel, sweat, and stale bread. Kapitänleutnant Hans Keller grips the handles of the periscope, one eye pressed to the rubber cup. He is hunting. A convoy lies ahead, 20, maybe 30 ships, plodding westward in disciplined columns. Smoke trails mark their presence long before they appear. Keller's mouth tightens into a thin smile. Targets everywhere. He sweeps the lens across the line of freighters, already calculating angles, speeds, silhouettes. Then something stops him. There are too many, not just in this convoy, but behind it. And beyond that, another. He lowers the periscope slowly, uneasy. "This is the 3rd convoy in 12 hours, he mutters. The navigator frowns. Perhaps traffic has been rerouted. Keller doesn't answer. He has been at sea since 1940. He knows the rhythm of Allied shipping. This is different. Back at BDU headquarters in Carnival, France, the numbers are piling up on Admiral Karl Dönitz's desk. Sinkings remain high, sometimes spectacularly so. But the tonnage curve is no longer bending the right way. For the first time since the war began, German analysts are forced to write an unthinkable sentence. Enemy replacement exceeds losses. The implications are terrifying, because U-boats are not designed to fight factories. They are designed to hunt scarcity, and scarcity is disappearing. Across the Atlantic, in shipyards that never sleep, the Liberty ship program has become a machine unto itself. Welding is no longer experimental. It is standardized. Procedures are codified down to the inch, the ampere, the second. Every weld bead looks the same. Every section fits. The yards operate like assembly lines stretched across water. Hull sections arrive on rail cars, swing into place under cranes, and fuse together in showers of sparks. Where riveters once hammered for days, welders now seal seams in hours. A ship takes shape the way a sentence does, piece by piece, until suddenly it is whole. And the workers know what they are doing matters. They read about the Atlantic in newspapers. They see the casualty lists. Some have sons in uniform. Some have husbands lost at sea. They work faster anyway. Not because they are ordered to, because they understand the math. Back in Germany, Donitz convenes emergency meetings. The Wolfpack doctrine, massed attacks, overwhelming force, is still sound. But something is wrong. Too many escorts, too many convoys, too many ships. In April 1943, the Germans introduced new weapons: acoustic torpedoes, improved Wolfpack coordination, longer patrols. They push harder, and for a moment, it seems to work. March is bloody, April worse, but then May comes, and May breaks them. In the span of 4 weeks, the U-boat arm loses 41 submarines, more than any previous month. Crews die faster than they can be trained. Veteran commanders vanish beneath the waves. Allied air cover stretches farther than ever before. Escort carriers prowl the gaps. Radar finds what eyes cannot. Sonar pins boats down until depth charges finish the job, and still the convoys come. A German signals officer notes bitterly in his diary, "We sink ships daily, yet the sea is more crowded than ever." That is when the realization sets in. This is not a battle Germany can win, because for every submarine lost, it takes years to replace the crew. For every freighter lost, America replaces it in weeks, sometimes days. The welding shortcut, once mocked as crude, dangerous, irresponsible, has rewritten the strategic equation. Steel, not tactics, now decides the outcome. In Washington, Admiral King reviews new production figures. He does not smile. He simply circles a number in red pencil. 2 Liberty ships launched every day. By the end of 1943, the Allies possessed something unprecedented in naval history: surplus shipping during wartime. Cargo piles up in British ports faster than it can be unloaded. Vehicles wait in holding yards. Fuel depots expand inland. The question is no longer, can we supply an invasion? It is, where do we land first? In Germany, the opposite problem emerges. Raw materials run short. Skilled labor disappears into the army. Bombing disrupts rail networks. Submarine yards struggle to maintain output even as losses mount. Donitz orders boats withdrawn temporarily from the North Atlantic. It is an admission, even if no one calls it that. The wolves retreat, and the sea, once Germany's greatest hunting ground, becomes a highway. Crowded, relentless, unstoppable. All of it enabled by a decision made in a cold room in Washington, when someone chose speed over perfection and welded steel instead of hammering rivets. Section 4. Cracks in the Miracle. January 16th, 1944. North Atlantic, off the coast of Newfoundland. The wind howls across the deck of the SS Schenectady like a living thing. Ice clings to railings and hatches, turning steel slick and treacherous. Below deck, the ship's boilers thrum steadily, heat pushing back the winter cold. Then, without warning, the sound changes, a sharp crack like a rifle shot, followed by another, and another. Crewmen freeze. One of them turns just in time to see the impossible happen. The ship's hull splits open, not at a seam, not along a plate edge, straight through the steel. In seconds, the Schenectady breaks nearly in half, the bow sagging away from the stern as seawater pours into the gap. There is no explosion, no collision, just a clean, horrifying fracture. Steel failing as if it were glass. Miraculously, the ship is moored. No one is killed, but word spreads fast. By morning, engineers, naval officers, and metallurgists swarm the dock. Photographs are taken, samples cut, measurements recorded. The miracle of welded ships has revealed its dark side. Cracks, brittle fractures, entire hulls failing without warning. By early 1944, more than 500 welded ships have reported significant cracking. Some are minor, others catastrophic. A handful break apart at sea, vanishing without distress calls. The press is kept quiet. But inside the program, alarm bells ring. Welding saved time. But steel behaves differently without rivets. Riveted hulls flex. Welded hulls, rigid and continuous, transmit stress like a lightning bolt. Add cold temperatures, poor quality steel, rushed workmanship, and sharp internal corners, and the result is sudden failure. The Germans hear rumors. They hope, if American ships are breaking themselves apart, perhaps the tide can still turn. But the response is swift and ruthless. At the National Bureau of Standards, teams work around the clock. Engineers like Dr. Constance Tipper, a British metallurgist brought in as a consultant, conduct fracture tests, deliberately breaking steel plates in cold chambers to understand how cracks propagate. The findings are brutal in their simplicity. Steel becomes brittle in the cold. Sharp corners concentrate stress. Welds are not the enemy. Ignorance is. Within weeks, fixes roll out across every yard. Rounded hatch corners replace square ones. Steel composition standards tighten. Welding procedures change. Preheating plates, controlling cooling rates, inspecting seams with new rigor. Ships already built are retrofitted. Ships under construction are redesigned midstream. The assembly lines do not stop. They adapt. That is the difference. Where Germany must halt production to retool, America absorbs failure and keeps moving. By mid-1944, hull fractures drop sharply. By 1945, they are rare. The Liberty ship, once derided as a floating coffin, proves itself where it matters most. Not in perfection, but in persistence. They keep sailing. They keep delivering. They keep arriving. And the sheer scale overwhelms every remaining German countermeasure. In June 1944, as Allied forces storm the beaches of Normandy, Liberty ships crowd the English Channel, their holds packed with tanks, trucks, ammunition, rations, fuel, the physical mass of invasion. From the cliffs above Omaha Beach, German observers watch in disbelief as ship after ship unloads. Undeterred by weather or losses, one officer writes later, "We destroyed what we could see. More always appeared. The welded hulls endure groundings, near misses, even mine damage. Many limp back to port scarred but intact, repaired in days and sent out again. They are not elegant. They are not fast. They are unstoppable. By late 1944, U-boats that dare to surface risk immediate destruction. The Atlantic is saturated with Allied air patrols. Sonar blankets the depths. Escort groups hunt submarines for sport. The strategic balance has collapsed completely. Germany's naval war, once poised to starve Britain into submission, has instead drowned beneath American production. And at the center of it all stands a man few sailors will ever meet. Henry J. Kaiser. He visits yards occasionally, sleeves rolled up, talking to welders and foremen, urging them to find faster ways, better methods. When someone tells him something cannot be done, he asks how long it would take if it had to be. The answer is always shorter than expected. In a war defined by machines, Kaiser understands something fundamental. Victory does not belong to the side with the best weapon. It belongs to the side that can build tomorrow's replacement faster than today's loss. The Germans never solved that equation. And by the time they understand it, the ocean itself has turned against them. Section 5. Faster than the ocean could swallow. March 23, 1944. Richmond, California. Kaiser Shipyard No. 2. The horn sounds at dawn, long and low, echoing across the mudflats of San Francisco Bay. Thousands of workers stream through the gates. Welders, pipe fitters, electricians, crane operators, men and women in coveralls still stiff with salt and grease. Some have never seen the ocean before this war. Now they are reshaping it. On the slipway, the keel of a Liberty ship already looks complete, and it is barely a week old. A foreman checks his watch. Another checks a clipboard. Above them, cranes swing prefabricated hull sections into place with mechanical precision. Welders strike arcs in unison, white light flaring like controlled lightning. The ship is not being built, it is being assembled. This is the final evolution of Kaiser's idea. Modular construction perfected. Hulls are broken into hundreds of standardized blocks. Bow sections, stern frames, engine rooms, deckhouses. Each is built indoors, shielded from weather, worked simultaneously by specialized teams. When ready, the blocks are lifted and joined like pieces of a colossal steel puzzle. No rivet gangs shouting, no months of sequential labor. Just parallel motion, everywhere, all at once. Germany cannot comprehend this. At German yards, ships still grow slowly, plate by plate, constrained by skilled labor shortages, bombing damage, and rigid tradition. Each vessel is a bespoke project. Each loss hurts. In America, loss is noise. By spring 1944, the U-boat fleet is dying not because it is hunted, but because it is outpaced. In Berlin, Admiral Karl Dönitz studies grim charts. Sinkings are down. Construction delays mount. Fuel shortages limit training. New submarines reach the water with crews barely qualified to operate them. Meanwhile, American yards are launching ships faster than German captains can learn their names. One Liberty ship every 3 days, then 2, then more. The record-breaking SS Robert E. Peary was a stunt. But the real achievement is consistency. By mid-1944, average construction time stabilizes at under 40 days per ship. Some yards do better, some do worse. It doesn't matter. The numbers overwhelm everything. In the North Atlantic, convoy escorts report something new. Where once the ocean seemed empty after an attack, now replacement ships arrive before wreckage has sunk. Cargo lost 1 week is replaced the next. British dock workers joke darkly that American ships arrive faster than they can unload them. But behind the humor is awe. The war has become arithmetic. Every German torpedo represents hours of lost work. Every American ship represents thousands of hours regained. And America has more hours than Germany has torpedoes. The real miracle is not steel. It is people. Kaiser's yards draw workers from everywhere. Farmers from the Midwest, Dust Bowl refugees, Black Americans escaping Jim Crow violence, women entering heavy industry for the first time. Training programs turn novices into skilled welders in weeks. Mistakes are corrected, processes refined, failures absorbed. Where German industry punishes error, American industry studies it. By 1944, productivity per worker has doubled. Accident rates fall even as speed increases. Welding, once feared, becomes routine. The cracks are remembered, but no longer feared. At sea, U-boat commanders report the psychological shift. They are no longer hunters. They are hunted curiosities. Allied air patrols close the Atlantic air gap. Radar and sonar erase darkness. Hedgehog and depth charge attacks pound the ocean floor. When a submarine surfaces, it dies. When it stays submerged, it starves. One captured German officer later says simply, "We could not sink ships as fast as they appeared." That is the war, distilled. By the time Allied armies break out of Normandy in August 1944, supply is no longer a constraint. Tanks roll because fuel exists. Artillery fires because shells arrive. Infantry advances because boots, food, and replacements are waiting. None of it is glamorous. All of it is decisive. Liberty ships are everywhere. Rust-streaked, blunt-nosed, anonymous. Their crews know they are not fast enough to outrun danger. But they also know something else. If they are sunk, another will follow. If they survive, they will sail again. By war's end, over 2,700 Liberty ships will be built. Thousands more Victory ships will follow, faster, stronger, improved versions born from the same philosophy. Germany never recovers. Its shipyards bombed, its steel rationed, its workforce drained. The Atlantic, once a killing ground, becomes an Allied highway. And the reason is not one man, not one ship, not even one technology. It is a decision, made early, defended ruthlessly, corrected when necessary. A decision to build faster than destruction. Henry Kaiser will later say he did not invent welding. He simply refused to accept that it couldn't replace rivets. That refusal changed the war. The ocean tried to swallow America's ships. America answered by building more water than the ocean could hold. Section 6. The war is won in the yards. January 12, 1945. North Atlantic, aboard USS Bogue, escort carrier. The wind howls across the flight deck, carrying the smell of fuel and cold steel. Below, gray waves stretch to the horizon. Empty now. Too empty. Lieutenant Commander James Collins lowers his binoculars. 6 months ago, this stretch of ocean would have been a graveyard. Smoke columns, lifeboats, oil slicks spreading like bruises across the water. Now there is nothing. No U-boats, no convoys under attack. Just endless gray and the steady thrum of engines. The Battle of the Atlantic is already over. Even if no one has officially said so, the final German submarines still exist. But they operate like ghosts, afraid to surface, unable to strike. Their captains know the truth. Even success no longer matters. Sinking one ship means nothing when 10 more appear behind it. Back in the United States, the shipyards do not slow down. They cannot. The war has grown too large. Liberty ships that once carried food now haul tanks. Victory ships bring locomotives, bridges, hospital equipment. Entire armies are floating across oceans on hulls welded by men and women who, 4 years earlier, had never held a torch. In Richmond, California, a welder named Eleanor Martinez finishes a seam along the deck of a Victory ship. Her mask comes up. She checks the bead, smooth, even, flawless. She learned to weld in 10 weeks. Her brother fights in France. She has never been there, but part of her is already on the continent. This is the unseen front, not Normandy, not Bastogne, but the yards, where the war is decided hours at a time. German intelligence reports finally reach Hitler's desk in late 1944. The numbers are incomprehensible. Thousands of ships, millions of tons of cargo, replacement rates that defy logic. He dismisses them as exaggeration. By then, it no longer matters. Even as the Reich collapses, American shipyards are preparing for something else. The invasion of Japan. Plans call for more shipping than any operation in history. More than D-Day. More than North Africa. The yards respond without hesitation. They expand again. But the invasion never comes. In August 1945, the war ends abruptly. The yards fall silent. Torches go dark. Cranes stop moving. Men and women walk out through gates they entered every morning for 4 years, unsure of what comes next. Some ships are mothballed. Others are sold, scrapped, repurposed. But the method survives. Welding replaces riveting across the world. Modular construction becomes standard in shipbuilding, skyscrapers, bridges, pipelines. What began as a wartime gamble becomes industrial doctrine. Historians will later argue about tactics, generals, battles. But logistics always win the argument in the end. Germany lost not because its soldiers lacked courage, not because its weapons lacked innovation. It lost because it could not replace loss fast enough. America could. Henry Kaiser never designs a battleship, never commands a fleet, never fires a shot. Yet his decision to trust welding, to break ships into modules, to build faster than tradition allowed, does more to defeat German submarines than any depth charge ever dropped. The Atlantic did not turn in a single battle. It turned quietly, in yards filled with sparks, in seams cooling under midnight air, in ships launched before their names had dried on the bow. This is how industrial wars are won, not by stopping destruction, but by making it irrelevant. Section 7. The Reckoning of Steel and Time. October 3, 1946. Washington, D.C., Navy Department Building. The war rooms are quiet now. Maps that once crawled with pins and grease pencil arrows have been taken down. The walls are bare. In a long conference room overlooking the Potomac, a small group of naval officers, civilian engineers, and analysts sit with thick folders spread before them. This is not a victory celebration. It is an autopsy. Rear Admiral Francis S. Lowe adjusts his glasses and looks down at the numbers again. He has seen them before, but they still feel unreal. More than 2,700 Liberty ships built. Over 15 million tons of cargo delivered. U-boat sinkings reduced to statistical noise by late 1944. And then there is the figure no one can ignore. Average construction time per Liberty ship in 1941, 230 days. Average by 1943, 42 days. Record, 4 days, 15 hours, 29 minutes. The room is silent as that last number hangs in the air. One civilian analyst breaks it softly. Germany never had a chance to keep up. He is not boasting. He is stating a physical reality. The Kriegsmarine's entire U-boat strategy depended on arithmetic. Sink ships faster than they can be built. It had worked once in the First World War. It nearly worked again in 1942, when American coastal defenses were unprepared and U-boats hunted freighters within sight of beach lights. But arithmetic cuts both ways. Germany could build submarines by the hundreds. America could build ships by the thousands. And time, the most important resource in war, belonged entirely to the shipyards. In post-war interviews, captured German naval officers speak with startling honesty. Admiral Karl Dönitz, the architect of the U-boat campaign, admits the truth plainly. "We lost the Atlantic not at sea," he says, "but in the enemy's factories." He is not speaking metaphorically. He means the yards, the welding bays, the cranes, the human conveyor belt of steel and labor that no amount of tactical brilliance could disrupt. Back in Richmond, the yards are almost unrecognizable. Slipways are empty. Grass grows between rails where hull sections once rolled day and night. Some welders return to farms, shops, schools. Others stay, helping convert wartime industry into peacetime production. Eleanor Martinez keeps welding. Only now, she works on bridges, highways, buildings that will stand for decades. She never meets the men who survived because her ships arrived on time. She never sees the battles her labor enabled. But history sees it. The Liberty ships themselves do not age gracefully. Many suffer from brittle fractures, a flaw of rushed metallurgy and cold North Atlantic waters. Critics point to this as evidence that speed came at a cost. They are right. And they are missing the point. The Liberty ship was never meant to last forever. It was meant to arrive, to deliver, to be replaced if necessary. Longevity was a luxury. Victory was not. Modern shipbuilding still carries the DNA of those wartime decisions. Modular construction, prefabrication, welding as default, industrial scalability as doctrine. Even today, when a ship is assembled in sections across continents and joined into a single hull, the ghost of the Liberty ship is present. So is the lesson. Wars between industrial powers are not decided by single weapons or singular genius. They are decided by systems, by how fast a nation can learn, how fast it can adapt, how fast it can replace loss. Germany built better submarines. America built more everything. And in the end, steel does not care about courage. Only quantity, only time, only whether the next ship is already sliding down the ways while the last one is still sinking. That was the welding shortcut. That was the quiet revolution. That was how America built warships faster than Germany could sink them.